Hello everyone, today we're looking at lesson 3 of our trig identities unit, and this is symmetry and cofunction identities. Okay, first thing we're going to do is figure out which of the 6 trig functions has even symmetry, odd symmetry, or neither. So I'm just going to quickly draw them. We're not going too in detail with the graphs of the 6 trig functions. Okay, but we are going to start with sine x, and sine x looks like this. Sorry. Okay, so that's sine x. And we can see if we look right at the origin, it goes up and to the right and down and to the left. So that is going to be odd symmetry. Okay, what about um, the reciprocal function of sine, which is cosecant? So y equals cosecant x. And cosecant x looks like this. Okay, again, if we look up to the right of the origin and down to the left, so it will also be odd. Okay, cosine this is the cosine, and cos x, we're looking at the y-axis. Everything that happens to the right also happens to the left, so this will be an even symmetry graph. And then if we look at secant, which is the reciprocal, just like the other one, it touches on the maximums and minimums. And it will also be an even graph. And then finally, tan. Let's go back to red. Tan looks like this. Great. And then cotan, so sorry, that is an odd symmetry. And then cotan it just looks like the opposite. Then will also be odd. Okay, remember even odd if, for those of you who aren't remembering, let's say when x is 1, y is 1. When x is -1, y is -1. So those are odd because if you change the sign, it's the opposite. Cos was even because when x was 1, say y was there, but when it was -1, it was at the same y value. Okay, great. Use the above information to complete each symmetry identity. write each expression in terms of the original trig function. Okay, so we need to remember here that even symmetry functions, if we make the x negative of the original function, it won't matter. We'll still get the same answer as the original function. And for odd, if we make x negative compared to the original function, we will get the opposite. Okay, so for sine x, or if we're making it negative, whatever theta is, if we make it negative because it's odd, we will get negative sine. Okay, we're using our graphs. Cosecant was also odd. So it'll be the negative. The coses were even. So we will get the negative theta plugged into a cos would give you the same value as the positive theta plugged into cos, and same with secant. And then tan is odd, so we'd get negative tan and negative cotan. Okay, what is the cosine of angle A? Okay, so we see that angle A up here, cosine is adjacent over hypotenuse, so the adjacent is 4, the hypotenuse is 5. Okay, what is the cosine of angle B? So angle B is down here, cos of B, the adjacent changes to 3. Okay, sine of A, so sine is opposite over hypotenuse, and sine of B, opposite over hypotenuse. And what can we gather here? That cos of A is equal to the sine of B. Okay, and if we think about degrees, or so the angles inside of a triangle, so we have this box that represents 90. So we know that the other two angles have to equal 90 when added together. And that tells us that cos of A, well, if we're looking at angle B, it must actually be the sine of 90 take away A, right? B is what's remaining when you subtract angle A from 90. Okay, what about sine A, which is equal to cos B? And again, same premise, so sine A is equal to the cos of 90 take away A. Okay, and these are things we might come back to later. Write a general rule that summarizes the relationship between the two acute angles in a right triangle. Okay, so you have a right triangle here. So the two acute angles, we have one here, one here. Let's just call them A and B. Well, what we know is that A plus B plus C, so C would be the 90 here, must equal 180. Again, we know that C is 90, so A plus B plus 90 equals 180. So if we subtract 90 from both sides, we get that A plus B equals 90. And that tells us that angle A is going to be 90 degrees take away B. And angle B is equal to 90 degrees take away A. Okay, express this relationship in mathematical notation as an identity in two different ways. These identities are known as the complementary function or cofunction of identities. All right, so we wrote that cos A is equal to the sine of 90 take away A, and we wrote that sine A is equal to the cos of 90 take away A. Since we are in grade 12, we're talking about radians. Mostly we know that 90 degrees is equal to pi over 2. And so to put it into advanced functions terms, we are going to say that cos A is equal to the sine of pi over 2, subtract A, and sine A is equal to the cos of pi over 2, subtract A. Okay, so it's just putting it into radial terms. Rewrite each of the following trig ratios in terms of its cofunction. Okay, so cos 48. So we know that if 48 is represented by A in our terms above, right? This is degrees, and cos A equals sine of 90 minus A. So it's going to be the sine of 90 take away 48 because that represents A. So it's actually the sine of 42 degrees. Okay, in radian terms, so sine of pi over 3 is the same as cos of pi over 2 take away A in this term, pi over 3. And we know we have to have common denominator to subtract fractions. So pi over 2 is the same as 3 pi over 6. Pi over 3 is the same as 2 pi over 6. So sine of pi over 3 is the same as cos of pi over 6. Okay, cosecant. So just like sine, the sine A is cos of something, cosecant A is going to be the secant of 90 take away A. And finally, cotangent. So cotangent goes with tan. So this is going to be the tan of pi over 2 take away A. Again, we need common denominator. So we have 5 pi over 10 minus 2 pi over 10. And it will be the tan of 3 pi over 10. Great. Periodic identities. So periodic identities are like coterminal arms. Okay, so we're adding something. If we look at way at the top, our sine function. So here's where it starts. The next time it gets there is one full cycle, one full circle. Cycle and circle, same thing here. So it'd be theta plus 2 pi because it's taking another 2 pi to start the cycle. So sine theta would be the same as sine theta plus 2 pi. Okay, again, if you want a quick diagram, Okay, here's our original sine. And then at 2 pi, it starts over. Or you could go backwards 2 pi. Okay, so this point is 2 pi. But it looks the exact same, just shifted 2 pi over. Okay, cos, you start at the top, work your way down, top, and then it would be the same thing over again, or backwards. Okay, again, we are shifting 2 pi over, so cos theta is the same as theta plus 2 pi. And then finally tan. So tan's a little bit different. Goes like this. Okay, and for the next time that it's identical is actually just 1 pi over. Okay, so we have 0 here, and then we have pi here. So it happens all over again, each pi cycle. So tan would be the same as, let me put pink, the tan of theta plus pi. Okay. Now we have all of these equations, so like sine pi take away theta, and we want to know if we're going to get a positive sign or a negative sign. Okay, is it equal to positive sign or negative sign? And for that, we're going to use the circle. Okay, we have a circle. Theta represents an acute angle. So what it's saying is if we worked from pi and we subtracted, in this first one because it's pi take away theta, we subtracted an acute angle, we would end up in the quadrant where, just let me write cast, we would end up in the quadrant where sine is still positive. Okay, so pi, sine of pi take away theta will be positive sine theta. Okay, what if we started at pi and, well, we took away theta, we're still in quadrant 2, which makes the cos negative. Okay, so all these pi take away theta, that means they end up in quadrant 2. So sine should be the only positive one. Okay, now we have pi plus theta. Well, if we're adding theta, so we're adding an acute angle, we'll end up in quadrant 3. And based on CAS, we can see that the only one that should be positive is tan. So sine and cos will both be negative. Okay, and then the last one, let's go blue, 2 pi. Okay, so we know that 2 pi is the same as 0. And we're taking away an acute angle, so it's going this way. And that means it's in quadrant 4, so the only one that should be positive is cos. So that means tan is negative and sine is negative. Okay, just in case we come across these sine pi take away theta, sine pi plus theta, we know that it's going to be either the positive or negative depending on what quadrant we're in. Okay, now we can use these to simplify this next question. The cos of negative theta plus cos of 180 take away theta plus or minus cos 180 plus theta. And remember, pi and 180 really mean the same thing. Okay, so let's look up here. So the cos of negative theta, if we go all the way, the cos of negative theta is even, so it would be positive cos theta. So we're going to replace this with just cos theta. Okay, the cos of pi take away theta, or 180 take away theta, gave us a negative cos theta. Okay, if you're not understanding that, I'm getting that from here. And 180 plus theta, which is here, is also negative cos theta. Okay, so we have cos theta plus a negative, so take away, you know what, I'm just going to get rid of the double signs. Cos theta, take away cos theta, and then we have minus a negative, which is really plus cos theta. Cos theta, take away cos theta is 0. 0 plus cos theta is cos theta. Okay, so we've simplified it. So all that really just means positive cos theta. Okay, what if we go down here? So the cos of pi plus x, again, go over here, we have pi plus theta, which is the same as pi plus x. It's negative cos theta, so we have negative cos theta. The sine of pi minus x was positive sine. Okay, so we have plus sine theta. On our denominator, sine of 2 pi take away theta, which is negative sine, minus the cos of pi take away theta, which was negative, so we're minusing a negative cos. Okay, so get rid of my double signs. We have negative cos plus sine over negative sine plus cos. Okay, and you can see that the signs of the numerator are the opposite of the signs of the denominator, so the answer here would just be negative 1. Okay, those of you not understanding that, I can even put it in the correct order. So we have negative cos theta plus sine theta. If I want cos to come first on my denominator, it's positive and then negative. So they're the complete opposites, so negative 1.